Good afternoon, class. In today's video, what I wanted to do is to go over an example problem from the Coulomb's law review problems that I have on the Google Classroom. So let's go over an example. Now, if you want to follow along, this is number 20 on the homework set. So here we go. We got Q1 equals 1 Coulomb, Q2 is 1 Coulomb. We don't know what the distance is, but the force is 5 newtons. Now, the reason why I chose number 20 and not like number 1 or something like that was because solving for R is actually the hard one. And that's why I wanted to do the hardest problem to help you figure out, okay, this is because if I can do this, you can do this hard problem, then you can do the easy problems. And that's what I'm hoping that you'll find during this time, or at least in this example problem and in this homework set. So let's do this. We're going to use F equals K Q1 Q2 over R squared, but this time instead of really going for the, putting in like K equals 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. The reason why I didn't do that it was because I wanted to focus on how you handled this equation and not get bogged down by all that scientific notation and all those really large numbers over there. So I just wanted to make sure that that was clear. Like it is supposed to be quite a bit bigger. Like this answer is it's not nearly this small. It's actually quite a bit bigger. But I wanted to, avoid that for now, just so that you understand. But just to point out again that for this example, K is 1. We're just going to do that. But when you actually take the test, then K is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. So please keep that in mind. Okay, so all I do is again I take my equation and then I substitute all of the given information up here into it. So 5 newtons equals K, which is 1, then Q1, which is 1, Q2, which is 1, R squared we don't know, so we leave as R squared, and then we're good to go on that. Notice I'm also doing the shortcut method on this. That's why I don't have any units available, or at least written down, and I'm just going to assume them to work out at the end. Okay, so what I do from here is I'm going to multiply both sides of the equation by R squared, because R squared is in the denominator, and we don't want that. We want R squared in the numerator. We'll deal with the other parts to isolate our variable down to R, but for now, that denominator, that the R being in the denominator is a problem, and we need to solve that. So to solve it, we need to multiply both sides of the equation by R squared. So because R squared divided by R squared, which we remember from our drill, is 1. So we've now got 5R squared equals 1. So we divide both sides of the equation by 5. We get R squared equals 1/5. So then we can now square root the whole thing, because to isolate the variable, we need to do the opposite operation that's being done. So if R is being raised to the second power, we need to take the square root, or we need to take the second root in order to get rid of that second power. Of course, we do it to both sides of the equation. We've got R equals plus or minus the square root of 1/5. Now, I hope you noticed something. I actually didn't write plus or minus over here, and the reason why is because when we're talking about distances, there's no such thing as a negative distance. That, by definition, does not exist. There can be negative positions. You can have if you set a place that's 0 and you said this way is positive and this way is negative, you can set a position right over here as being negative because it's in the negative direction. But the distance between my finger and my thumb will always be positive, even if it's from here to here or from here to here. Always a positive distance, because it's just a number. It can't be negative. There's no direction involved in distance. So when I do this now, so my answer then so that's why I reject the negative and I just leave it as the positive answer. So that's why I didn't even bother to write it up there. So I thought I'd just let you know that for mathematical completeness. Now I've got R equals 1 over square root of 5. And the thing is, and most of your math teachers will actually say this as well, having a radical sign in the denominator is terrible. Do not do that. So in order to do that, we need to what we call rationalize the denominator. And of course you might say, what? How do we do that? And the answer is very simple. We multiply by 1. Hopefully you've seen that trick before when we did the other videos on at the beginning of the year about FOIL and reverse FOIL, possibly also during the completing the square videos, I talked about multiplying by 1 and how that is an awesome little trick to have in your mathematical toolbox. So in this case, what I do is I multiply by radical 5 over radical 5, or square root of 5 over square root of 5. So I'm multiplying by 1. I don't have to multiply both sides of the equation to do anything. And so now what I've got is I've got square root of 5 times square root of 5, or square root of 5 squared. And since we know that the square root is the inverse of something being squared, those square root signs cancel out, and so you've got just regular old 5 on the bottom in the denominator. Of course, we have to multiply the numerator. 1 times square root of 5 is still square root of 5, so we've got our final answer of r equals square root of 5 over 5 meters, because we want to make sure we answer the question with correct units. So that's how to answer number 20 in the Coulomb's law example. Good luck in your studies, and may the force be with you.